Hi everyone, welcome to our channel Tech Bytes with Dileep. Today we will be discussing about what is an embedded system and its classification. Coming to the first topic, embedded system. An embedded system is an electronic or electromechanical system which is designed to perform a specific function, a particular function. And this is a combination of both hardware and software. In technical terms, software is also called as firmware. Every embedded system is unique. Take an example of washing machine, refrigerator, printer. If you take an example of printer, it does only the printing task. Apart from that, it does not do any other task. So it's a unique device which does only one particular job. So it has the hardware as well as the software design. Take an example of printer or a washing machine or a refrigerator or any embedded system example for that matter. Everything contains some or the other hardware and some or the other software. So it is highly specialized to the application domain itself. So it does only one particular task. Now comes the classification of embedded system. Embedded systems are broadly classified into four types. One is based on its generation. Second one is based on the complexity and performance requirements. And third one is based on deterministic behavior. And fourth one is based on triggering. We will see one by one classification. Now, based on the classification of embedded system based on generation, it is divided into five types. First generation, second generation, third generation, fourth generation, and the next generation embedded systems. Now let's see the classification based on the first generation. These embedded systems are early stage embedded systems which were built around 8-bit microprocessors such as 8085 and Z80 and 4-bit microcontrollers such as 4004, and these are very much simple in hardware, and the software is developed in assembly level programming. Assembly level programming in the sense either they use microprocessor programming or microcontroller programming. And examples of the first generation embedded systems include digital telephone keypads, stepper motor control units, etc. Now let's see the second generation embedded systems. These embedded systems built around 16-bit microprocessors and 8-bit or 16-bit microcontrollers. The instruction set were much more complex here, and which is powerful also. The instruction set is powerful than the first generation. That means we have more number of instructions here, and the instructions are little complex to understand, but it has very much advantages and very advanced features. Some of the second generation embedded systems contained embedded operating systems also in their operation. Examples of this second generation embedded systems includes data acquisition systems and SCADA systems. SCADA system based on power electronics applications. As we can see from the diagram, we have a sensor over there. It converts or it gets the analog signal and it gives to DAC device, that is data acquisition device, and this is a signal conditioning device which is nothing but analog to digital converter. So here the analog signals, the real-time analog signals will be converted into digital signals which is understood by the computer. So computer gets the digital signals, processes the data inside it using the driver software and the application software and gives us the result. So we can use that particular digital signal and we can manipulate it according to our requirements. Next comes the third generation embedded systems. These are built around 32-bit microprocessor and 16-bit microcontrollers. And here application domain specific processors we will use like digital signal processors and application specific integrated circuits. And the instruction set is very much complex here compared to the second generation and the first generation. And even it is powerful also. Even though it is complex, it is powerful. It has many other features compared to second and first generation. Pipelining concept has evolved here. The meaning of pipelining is any instruction for that matter, if it has to execute, it has to undergo minimum 3 steps. So the minimum 3 steps are the 3 stages are fetch, decode, execute. So any instruction has to be fetched first from the memory, and then it has to be decoded, and then it has to be executed. So this we call it as a 3-stage pipeline. We have 4-stage, 6-stage pipelining, 5-stage pipelining as well. When it comes to this 3-stage pipelining, here I told fetching is fetching the instruction from the memory. This is the first stage. In the second stage, you have to decode the instruction, because the assembly level instruction we will understand. Move a comma b or move r0 comma a, if these kind of instructions are microcontroller instructions, we say these instructions will be understood by the technical engineers, but for the general people, move a comma b, this instruction, this terminology they will not understand, or even computer for that matter, it doesn't understand move a comma b. So for this reason we have to convert this particular move a comma b instruction set from assembly language to machine level language. For that you are going to use the decoding stage. So decoder is responsible for converting your assembly level codes into machine level code. Then comes the execution stage. If it is move, it does move operation. If it is add instruction, it does add operation, or any other subtract, increment operation also for that matter. Then we have application areas of this third generation embedded systems include robotics, media, networking, industrial process control, and many more. So here we can see from the diagram, here you have a printed circuit board. There multiple slots have been given for interfacing the ICs or few external devices. Along with that you have few ICs which is embedded in it or integrated on it, and then you have few capacitor or resistors and few switches you can see there. Now comes the 4th generation embedded systems. The best example of this is your smartphones. So a few more examples are system on chip devices, reconfigurable processors, multi-core processors. And what are the advantage of this 4th generation embedded systems? It brings very much high performance, and then it is having tight integration into the embedded device market. The meaning of tight integration into the embedded device market is it is more useful nowadays, because many people use the smartphone itself. Nobody use Nokia 1100 or like that. So everyone uses the smartphone, which has many features like internet, Wi-Fi, music player, many apps, shopping apps, social medias, etc. Now the system on chip implements a total system on chip by implementing different functionalities with a processor core on a integrated circuit. That means it is in a single chip, it has all the systems, all the input system, output systems, processing systems, memory system, and everything. It makes use of high performance real-time embedded operating system. So if you want to do the 4th generation embedded system device, then you got to use the real-time embedded operating system itself. So even though it is little difficult to use, we got to use that itself. Examples of smartphones are depicted in the figure there. Next comes the next generation embedded systems. It has the processor and the embedded market, which is very much highly dynamic in this stage and demanding also. The next generation embedded systems are expected to meet the growing demands of the market because we have many IoT enabled devices which is coming now, and best example is Alexa. We know what is the advantage of Alexa. We can, by sitting on the chair itself, you can turn on the music, or you can instruct Alexa to do some particular task for you. So that is the next generation embedded systems are targeted to use. Thank you for watching this video. If you like this video, please like, share and subscribe to our channel Tech Bytes with Dileep. Feel free to comment your views and queries.